Hello, my name is Amartya Hatua, and I'm going to talk about my final project on unlearning of Llama. Machine unlearning is a process where a machine learning model is trained to forget specific data points or the influence of the data without retraining the entire model from the scratch. In this current project, we are using a Llama model, Llama 3 model for the machine unlearning task. The objective is implement targeted unlearning mechanism on large language model, then evaluate the forgetting effectiveness as well as preserve model utility post unlearning. So in a typical unlearning setup, we have to take care of two things. First, the effectiveness of unlearning. At the same time, we need to take care of the model's utility because the unlearning process should not affect the other parameters or other knowledge of the model which may degrade the performance of the model. For the unlearning task, we are using TOFU, a task of fictitious unlearning. It's an open source database available on Hugging Face. So this database is having some information about fictitious author, and it gives a context and also gives a dedicated forget set. So this data set is very appropriate for this kind of task. The method is used here is gradient ascent unlearning method, which helps us to increase the loss while optimization. So the image here clearly depicts the entire objective of this project. So first, we are downloading pre-trained Llama 3 model. Then the model is fine-tuned using the TOFU dataset. We're using the entire dataset, the first at the beginning. Then a selected part of the dataset, which is labeled as forget dataset, is further used to fine-tune. Now this part is basically we are calling it unlearning process. And once that is done, then unlearned model is ready. So the unlearned model has partial knowledge of the entire TOFU dataset, and we are testing whether the unlearning is effective or not using another model which is trained and which is pre-trained and fine-tuned with retained dataset. So the retained dataset is basically the remaining portion of TOFU dataset once forget dataset is taken out of it. This project aims to implement machine unlearning on a fine-tuned Llama 3 model using the TOFU dataset by selectively removing specific data and subsequently evaluating the unlearned model in terms of its retained utility and the effectiveness of unlearning. The following steps are performed to achieve the objectives. First, adapt the pre-trained Llama 3 model to a specific downstream task using the full TOFU dataset. Next, choose a specific subset of training example to be forgotten by the model. Here we are using the forget set given by TOFU dataset. Number 3 is remove the influence of the selected data from the fine-tuned model using custom trainer class. Then we are checking the model utility, assess whether the model maintains performance of non-forgetting data, and lastly, unlearning performance, measure the extent to which the model has truly forgotten the selected data. So unlearning task definition, TOFU includes a clearly defined unlearning task where part of the data used to fine-tune a model is later designated as the forget set. Dataset description. The dataset consists of fictitious author profiles used to generate question-answer pair. Composition of data used for this project is the full dataset initially where 4,000 pairs of question and answer present. In the forget dataset where 10% of the whole dataset, that is 400 question answer, and the remaining is the retained set, which is 3,600, and holdout set is 400 question answer. Again, holdout set is used for checking the performance of the model. Dataset access. The dataset is available on Hugging Face and it can be loaded using the platform standard data loading procedure format. The dataset is modified to alpaca style of prompt formatting, making it well suited for the instruction tuned LLM focused on question answer task. And the dataset is available in the following links. And the general knowledge dataset is also used here, which is not under TOFU dataset. General knowledge is used to check the effectiveness of the models when we are asking any question beyond the domain of TOFU. So this is an example of TOFU question and answer. and we are using this is 4,000 total dataset. We are using this for our fine tuning, unlearning, and retaining. So fine tuning and unlearning. So model and fine tuning setup. So all the experiments are conducted on Llama 3 model. So the Llama 3 itself running, it's little difficult in our normal Google Colab platform. So I have used Unsloth library where 4-bit quantized version of Llama 3 available, which helps us fine tune the model very easily. And PFT technique is used, specifically the LoRa is being used, and it modify specific layers of the model, and it helps the model to use for a particular task. Then SFT trainer, which is a supervised fine tuning trainer use, and it adapts the specific task for the full data set. Now this has a lot of parameters before going for final training process. We need to set all of them, and for this whole process, mostly the parameters are same except the data set name, and for unlearning the number of epochs are reduced, otherwise rest of the parameters are same. So the fine tuning and unlearning part, which is this is the central idea of the whole process. So in first fine tune the entire data set using the pre-trained model. Then once that is done, then the further unlearn process is started using the gradient ascent optimization. And here you can see the loss is negative, so we're trying to increase the loss. It's like if we want to learn something, we try to decrease the loss, and it's just the reverse way. We're trying to forget the selected amount of data set. And this gradient ascent SFT trainer, this is a custom class has been written. So instead of calling SFT trainer for unlearning purpose, we are calling this, and the rest of all the parameters of SFT train is the same, except the epoch is reduced to 5. Why it is reduced to 5? Because I have checked multiple epochs. I have experimented with it, and I observed if I go beyond 5, the performance of the model is pretty bad, and it is not able to generate any question answer, or it is just repeating one or two words, and it's not making any sense. So with the trial and error method, I have decided it to 5. Beside unlearning the Llama 3 model, one more fine tuning is also done on a pre-trained Llama model, and in that case the fine tuning is done on retain 90% tofu dataset. So the idea is, in an ideal scenario, the unlearned model is forgetting 10% and it is holding 90% information. Similarly, the retained model is pre-trained Llama model and fine-tuned with that 90% of tofu dataset. Now, in a ideal condition, these two models should work or behave similarly. Now, to understand the effectiveness of our unlearning process, our result, the unlearned model result is compared with the retained model result and checked how close they are. Dataset for evaluation is tofu's holdout 10% dataset, which is within the domain of tofu, and then the general knowledge dataset is also used to check uh, the out of domain performance of the models. The evaluation metric the for the model utility is being used as rules. It is comparing the data generated by the retained model and unlearned model, and further the comparison strategies evaluate both the unlearned and retained model on each dataset and enables the performance comparison within the domain and on general knowledge. So to access how unlearning affected model utility across task-specific and general context, this kind of evaluation matrices has been set up. This is the performance comparison of the retained model and unlearned model on TOEFL holdout dataset, and we can see the retained model is performing much better than the unlearned model in all the three scores, such as RUSE 1, RUSE 2, and RUSE L. So we can conclude the unlearning has a broader impact beyond the specific forget set, and it negatively affects related or semantically similar information as well. So this is another performance comparison. The performance is compared between the retained model and unlearned model for the general knowledge dataset, and we can see here the the scores are pretty similar, very close. So which is not the case in the earlier dataset. So we can conclude from here that the learning process has minimum impact on the model's performance while it is outside of tofu domain, and it indicates domain-specific forgetting is achieved effectively. Is the forget quality? We used KS test or two sample KS test. So here we have collected results from both the models, unlearned model and retained model, using TOFU's forget 10 dataset. Now the output has been collected and tested the distribution of the output, and we have found that the two test datasets are significantly different. It means uh, the amount of knowledge the unlearned model has, or the pattern it generates data, is very different from the retained model. So unlearning somehow affected just beyond more than the forget set, and that is the reason this of the dissimilarity of the distribution of the output. And this confirms our earlier result as well, where the tofu domain datasets ruse scores are pretty different. So somehow we can see that the domain specific unlearning is happened, but it also affected a lot of other factors. So in conclusion, I can say that it is successfully completed. Sorry. In conclusion, I can say it is a successful implementation of machine learning on Llama 3 model using TOFU dataset, and the gradient ascent based fine tuning is applied. The unlearned model, however, underperformed relative to the retained model on both forget and utility metric. Minimal performance loss on out-of-domain data, confirming the unlearning is largely domain-specific, and the case test results confirms a statistically significant difference between retained and unlearned output on the forget data. Hello, here is a short demo of my project. So I'm using Onslaught for fine tuning. So this Onslaught is installed and related libraries and been installed, and then these libraries are loaded first. Then the Llama 3 with 4-bit quantized version from Onslaught is loaded with tokenizer. Once that is done, I'm going for prepare the data, and using the particular format, the prompt format, the full data set of tofu is formatted with question and answer, and then the LoRa LoRa version of PIFT comes in the picture, and these are the target modules we are using here, and then SF supervised fine tune trainer comes, and we need to change the training data set. It should be the same as this data set name and the data field, which is text here. So text data field name should be changed, and rest of the things I kept almost as default, except the number of steps, which is 60 here, and I'm logging it in every 10 steps. So there should be 6 losses, training losses, and once that is done, my model is ready for fine tuning. I mean, the fine tuning is done. So this model can be used for inference. Now I'm just asking a simple question to check whether the tofu dataset is whether it is badly impacted or not. So we can save the dataset in a local machine. So first we can save here in Colab, then download it to local machine. So once that is done, my fine-tune model is ready. Then I need to do unlearning again, almost a similar process, but with a different type of data set. And once that is ready, which is forget 10, this is the class we have written for unlearning using gradient descent, and this class is custom class of SFT trainer. So instead of this, we SFT trainer will call gradient descent, and number of steps here I kept 5, because I have done multiple experiments and found that 5 is an optimum value here. Otherwise, if I increase the number of steps, the result is not that good and taking very long time. Once that is done, the model is ready for inference, and we can ask the similar questions, simple questions first that I have tested that was working fine. Then I have tested with, so you can see that the same question, where is Boston, and it was giving fine, proper result. Then I move to I run the holdout data set, holdout 10% for from tofu, and the Q&A. These two data set, all the questions been asked to the model, and the answer been saved. So Q&A has very long, it's been very big data set, so I have kept just first 1000 data points. And once that is done, I have saved the result and set the model. So this is this. So model fine tuning, unlearning process is done here. The retained model, the process is exactly the same, except there the data set is just retained 90%. That's all. And moving forward with the test or metric, here we are using the rows for tofu dataset, and you can see the rows values, 3 rows, 1, 2, and L, the values for written model and unlearning model. So you can see written model is performing better than unlearned model. Similarly, for out of domain dataset, which is a question answer dataset, general knowledge question answer dataset, you can see the performance is very close. So this suggests that the model is unlearning effectively for the in domain data. However, the interesting observation is, while unlearning in domain data, it is not only unlearn the forget data, it is unlearning something else as well, like the important data part. So yeah, that pretty much everything from the demo side.